This is shipping and mainly in charge of the application coding. And let me show you the application, how the application runs. So in here, when the application starts, it automatically tests two servers and shows its response time here. And based on which, it chooses which server to connect. URLs are shown here. And we can switch different machine learning algorithm here. So let's enter the username. If we click on the collection button, it goes to the collection page, and after 10 seconds countdown, it goes back to the main activity automatically. If we click on the login button, it tries to connect to the server and start the login procedure. And after after seconds, it shows it sums up the delay and computation time, and shows here. This is actually the execution time. If we enter another user's name, like Shibing, who is in the database, but however the EEG signal belongs to Rongyue, so if we click on the login, it returns as it shows the EEG password is incorrect. And if we enter somebody's name that is not in the database, it will show 0. So let us look at the code. The first part is just some necessary variables. OnCreate to create some necessary GUI. And at the end of the onCreate function, it tests both server and decide which to connect. So the server test is actually a synchronous task that tries to get a connection with the server. And if we click on the login button, it will cause the user login here. It will try to upload EEG signals and wait for successful failure response, and refresh the GUI in post execution function. Get battery level returns the battery level, and get execution time will get the execution time posted by the server.
This is the server to connect with Android. Here I will show you our cloud server which implemented on the Windows system. If I click the Run button, it will show the web page we want. This is our main pages. We created a UI for register and manage user name, also for brainwave signals, as well as a UI for user query. Here we have three main web pages. One is welcome main pages. One is admin interface, and one is login interface. The main pages shows the direction to admin pages and the login pages. If I click the admin pages here, you will see the UI for admin interface. Here we can manage the users in the database. We can see the username, ID, signature, file name, and the actions we want. Here we have 4 tuples in the database: 荣月, Shibin, Xu, and Ying. And then we can create a new user. If I want to create like this and select 放在这儿 we can choose a file we want to submit and click the button submit the query. We can see the successful information and click the admin pages and back to the admin pages, and here we can see the new user we added just before. And then we can also delete this user by clicking this button here, and then we can see the delete successful information. Go back to the user admin interface. We can see here we and go to login interface. In the login interface, we implemented 4 machine learning algorithm to classify the EEG signals for all users with open eyes and closed eyes. Here we classify the user with open eyes to log in, and otherwise we cannot log in. To show you 3 status, if the username and status have the same name and with open eyes, it will log in. And if the username and status is different name, even if it's open eyes, we cannot log in. If the username and status have the same name but with closed eyes, we cannot let it log in. And we will try the first situation. The username is 荣月. We try 90 days, and we select the open eyes for 荣月, and then submit the query. We can see the successful information. It's classified as open eyes, and it needs 48 milliseconds. And we will try the second situation for the Shibin's name, username, but with 荣月's open eyes. And submit the query. You can see it's an invalid signature, and the time is 34 milliseconds. And the third situation is Shibin's name, but with Shibin's closed eyes. Submit the query. It will not let it log in because it's closed eyes. And then we will try another situation. 荣月's name for the neural network for the open eyes. It should let it in. Let me see. You can see the successful information and classified as open eyes. And we can try another one. Oh, sorry. We can try another one with 荣月 and decision tree with open eyes of 荣月's file. This is a successful information for the decision tree. Let us try the last one. We have 荣月's username and select SVM. And we select open eyes for 荣月 and submit the query. We will wait for the result. The successful information for the SVM.
This is in here. In this project, I'm responsible for implementing 4 different machine learning algorithms in both in fog server and cloud server. And in this project, we in total implemented the 4 machine learning algorithms. They are naive Bayes classifier, decision tree, SVM, and neural networks. And during the data collection, we collected 35 open eyes and 35 closed eyes for each group member. And after that, we extracted 16 features for each EEG signal as shown here. Then we random selected 85% samples as a signature for each registered user. When we register a user, we upload the feature matrix as the signature for a specific user. During the authorization process, we could either use the Android app algorithm to auto-select the appropriate server, or we can directly use a fog server or cloud server to authorize a registered user. Here we show that how the accuracy of each machine learning algorithm. First, we will show the decision tree. Here we can see the accuracy for decision tree is 81%. Then we will show the naive Bayes accuracy. The naive Bayes is relatively quick, so we can see the accuracy is not that good. It's only 45%. And the third one will show the SVM accuracy here. Here we can see the accuracy for the trained SVM model is 100%. Then we will see how the neural networks work accuracy. Here we can see the accuracy for each part of the training data, validation data, and the test data. And for the total accuracy, it's around 57%.
Hello, my name is Lu. I'm a group member of Group 24. For this part, we will introduce how to set up cloud server and the fog server on a computer. The fog server uses the same network with the Android application, and the cloud server uses different network with Android application. First, we need to open the server part. I use PyCharm to open the fog server. For this part, we need to make sure this IP address should be the same with the computer's IP address. After that, we click this run button. After a few seconds, and the server will be start. After showing that, the server will start, and we can check this by clicking this web page. As you can see, our server has set up successfully, and we can also achieve user login and achieve an administration interface. And we can see the detailed connection information over here, and we can check this server has started successfully. In this part, we will introduce how to measure the power consumption for our Android application. We use the app Power Tutor to report our power consumption. After running Power Tutor, we can get a CVS file which contains the detailed information of power consumption, and we can use it to draw a picture of the power consumption and energy consumption. As you can see, the first picture is the power consumption, and the second one is for the energy consumption for our Android application. This is our task series, and we have complete the 19 tasks, and for the final one, we have not complete yet. The final one is write the final report. 可以吧？